Good morning, everybody. Welcome to the 10th edition of the annual climate conference at the Florence School of Regulation. My name is Simone Borghesi. I'm the director of the climate area of the Florence School of Regulation here at the European University Institute. Welcome to the conference. Welcome to Florence. Welcome to EUI. EUI is a special place. I hope you will enjoy it. It's a special place because it's a relatively new university. It was founded by the 6 original member states in 1972, so it's relatively new. But as you see, the place has a very old history, an ancient history that goes back to the roots of the city, I would say. You are here in the Badia. The Badia is said to be the legendary seat of the first bishop of Fiesole, San Romolo. It remained the bishop's seat for many years. But through history, we have had here the Augustine order. That's why it's called Via dei Roccettini. And through these places pass people like Cosimo I, the old one, or Pope Leon X, or Beato Angelico, the famous painter who was painting next door, basically, at the Convento, which is also another seat of EUI. So you are somehow immersed in the history of the place, but I would say in the history of Europe. So a perfect place for a European University Institute, I guess. The place is special to me as well because I took my PhD here many years ago. I took my first exams in this room, to be honest. And I came back 7 years ago as director of FSR Climate. Since then, many things have happened. Many good things, many bad things in the world, but that's something else. And among the many things that happened, there is something that remained constant, I would say, and it is this conference. Because I participated in the first 2 editions. I inherited the conference from Xavier Labandeira, who was the previous director of this unit. And I found it so good that I say, this has to stay. The fact that now we are at the 10th edition is a great satisfaction. I would say this is a milestone. And I am particularly glad to have you here today, to have reached this milestone. And that is why we will try to celebrate it as well, as good as we can. With a visit tonight at the Historical Archive of EUI. So, before we start with the program, I would like to say a few words to thank my team. I will introduce all of them maybe on the way because some of them are still missing. Someone is away for another event here again next door. Someone is far away in Budapest for one of the projects that we direct, but most of them are here, and I want to take this opportunity to thank them really from the heart because you do a great job, and this conference was possible thanks to all of them. Really a big thank. They fix problems all the time. The only thing they couldn't fix is my voice and my coughing after Baku, but for that I need a doctor, and the doctor didn't fix it either yet. So you don't feel responsible. And since this is the 10th edition, I think I should also thank the previous teams, because there is a high turnover as in any place, and we got here through all the teams that contributed in the past, since I was here, but also previously since Xavier was here. So without much further ado, let me go into the program. And the program starts really high with a first keynote by Maria Loureiro. Maria is professor in the Department of Fundamentals of Economic Analysis at the University of Santiago de Compostela, scientific director of the Inter-University Center for Business and Economics of the three Galician universities, ECOBAS, and among other things, she's a member of the Royal Galician Academy of Sciences and editor of Ecological Economics. In the past, she was professor at the Colorado State University, and her research is at the intersection, I would say, between energy economics, environmental economics, and agricultural economics. And today she's giving a keynote on a topic that is very timely, I'm afraid, given what we have seen in the past weeks and what we see on a daily basis, unfortunately, extreme events. So, Maria, thank you for being here. I'm particularly glad to have you here, and the floor is yours.
Thank you so much. Good morning, everyone. Thank you very, very much for this very kind introduction, Simone. Thank you to the organizing committee, and thank you for being here so early in the day. So for me, it's a pleasure to be here for multiple reasons. I have been only here once at this university, visiting Xavier, in fact, when he was the chair. And that was fantastic. And for me to come here today as a speaker, as a keynote speaker, having both of you on my side is a fantastic experience. So first of all, thank you for allowing me to be here, and thank you for being here today also. Well, my talk is going to be, unfortunately, related to extreme events, and unfortunately related to recent extreme events. And I call it climate and extreme events, a tale of social amplification of risk. Social with a small s on purpose, because I'm going to explain why is that. So let me walk you through what I'm thinking about telling you today. I'm thinking about trying to convey two ideas. Point one, we stress and we know very well through science that climate change is a crucial and fundamental problem for humanity. But nevertheless, when we estimate and we run these macro models, usually the expected losses are relatively small with respect to the GDP or general GDP. So what is happening if this is a crucial, drastic threat that is affecting humanity? How it comes that is not reflecting likewise in our estimates? And one of the reasons is because we are missing a huge elephant in the room. We are missing how to deal with extreme events. And this is what I want to bring to you today. Furthermore, I want to suggest that extreme events are very important in economic terms and social terms. And let me start my talk by referring to this graph, which is a publication from the Global Risk Report, just presented 2 weeks ago by the World Economic Forum, in which they show that extreme events or extreme weather events is the most important relevant threat worldwide. And it follows a second threat that you see there in purple, that is basically AI-related and misinformation events. So basically what I'm going to be showing, surprising for some of you, is that both circumstances, both events, climate-related events and misinformation at times are highly related. Furthermore, I could tell you that extreme events are related to many kinds of losses and risk in other sectors, including misinformation. So keep going through what the report is telling us. They are showing us risk in the short term and long term. In the short term, one of the most important risks that is reflected by the report, it accounts for, in fact, misinformation. Is the number one problem that is outlined in the report. Whereas a 10 years view, basically the report makes a lot of emphasis on extreme events, critical earth conditions, biodiversity losses, and natural capital loss. So these are the most important risks outlined by the World Economic Forum. So this should be considered into our work and our analysis. Another aspect that is being pointed out by this report is the interconnection or correlation of risks. So they are talking about systematic risks. that they emerge mainly at times in social or in extreme natural events, basically. These extreme natural events can be very devastating in nature, high risk, and not so low probability as they used to be. In fact, in the past, extreme events were very difficult to model because we needed to go through extreme value theory, which was rather difficult to implement. But nowadays, because of the high recurrence of these events, at times other more basic approaches applied in econometrics, such as count data models, work fairly well, unfortunately. So what I'm going to be saying today, or what I'm trying to represent, is the fact that when we look at extreme events, we should not only consider the economic and physical impact, but many other impacts that may be related to that, and that they already are being studied and analyzed in social sciences. And that's why we are going to be talking about the amplification of social risk, because we are certain that we're going to be facing situations in which systematic risks will be present in the future as well. So in economics, how we deal with all that, and how we have thought about looking at these events and climate-related events. Basically, our economic analysis boils down in the estimation of damage functions, right? And damage functions have been analyzed in the context of presenting traditional concerns that have been fairly studied in the literature, such as discount rate and functional forms, but also there are new concerns that emerge and arise and should be put forward, such as omitted variable bias, for instance, right? And new estimation techniques that may be more suitable for the kind of data we are dealing with. And when we do that, hopefully we will represent closely the impact of climate change, including hazards and extreme events. Let me go through very quickly about the discount rates that you are already very familiar with. Just to put you in context, what we are seeing in the last couple of years is that there is a reconsideration of the most appropriate discount rates to be used, particularly for long-term projects and particularly for projects in which health impacts are related. So the literature is coming to terms indicating that this 3% discount rate previously used by Nordhaus and many other scholars may not be the right discount rate. The discount rate may depend on the length of the project, of course, on the uncertainty that already Weissman indicated in his seminal work, but many other factors. And some of these factors refer to the damage per se. And for instance, there we have the Green Book published last year or approved last year by the UK government, where they implicitly indicate that the lower discount rate should be applied for projects involving human health or life outcomes. And that's quite interesting. So point one, what we should learn is that we should not be considering a unique discount rate, but we should be considering an array of discount rates depending on the certainty depending on the damages. A second consideration has been implemented or published also last year by the US Office of Management and Budget, and they published a new report on December 23rd, that basically they suggest or provide current guidelines for applying discount rates around 2%. And this is quite interesting because it represents a drastic drop with respect to previous discount rates that were between the 3 and 7% rates. It's quite interesting, the report they published. In bioeconomics last year and the Biocon conference, we provided a letter of support for this reduction of the discount rate. And it's very interesting to see how the Biden administration has implemented this new discount rate across the different policy agencies. So it's a nice way of looking. In Europe, unfortunately, we don't have a common view on what discount rate should be applied. And there is a lot of work coming from France, actually, that is a reference in the field. And there they suggest also declining discount rates over time. But unfortunately, as I say, the general vision in Europe and the European environmental policy is missing with respect to that. In terms of functional forms, that is something else that I wanted to talk about, let me say that historically there has been a huge emphasis between damage and temperature. And there has been a huge discussion, obviously, on what type of how the temperature should be included into the damage function. Should it be a linear modelization? Should it be a quadratic? Should it be exponential? How? So this is referring to the functional forms of the damage functions per se. I want to tell you that historically, the most traditional damage functions are only considering temperature as the crucial impact of climate change, or the representation of climate change and are being modeled with respect to losses on GDP. And although this approach is correct, unfortunately, many aspects such as climate extreme events are missing from this representation. And this happens not only on the initial work done by William Nordhaus, but many others. Until recently, that in new models such as the FANT model or the PH model, they are considering, for instance, biodiversity losses. But still, many improvements have to be implemented on IAM or integrated assessment models in order to come up with a proper representation of the damage function in terms of missing variables. This, of course, has drastic implications in terms of sensitivity of the parameters, but furthermore, in an aspect that the policymakers employ day by day, which is the social cost of carbon estimate. Of course, if we don't estimate well the damage, the problem that we are going to have is that when we monetize the damage and the discount value of that damage over a certain period of time, we will have a very low impact estimate, which translates in low cost of carbon or social cost of carbon. This is an example on how social cost of carbon has been estimated over the years. Richard Toll has done a literature review published in February 2024 in Energy Economics that shows basically how the impact functions or the damage functions have been estimated over time. As you see, only temperature and temperature square have been included, omitting relevant variables. And this has translated, of course, in an array very broad of different damage estimates, going from 40 euro per ton of CO2 until more recent estimates that go over 150 euro per ton. Why this change? Well, first of all, because when we drop the discount rate, of course, when dropping the discount rate, what it happens is that the total damage increases because you deflated less. So this is one of the main reasons. Others can be new inclusions of biodiversity losses in some particular models. But mainly, we are not there yet. What I'm trying to indicate today is that still more work has to be done in order to update these estimates, which are already in terms of 4 times what initially have been conceived, but still many relevant variables are missing. Also Toll, very productive, has published in September 2024 a meta-analysis with respect to the social cost of carbon estimates per year, published per year in the economic literature. And he is showing that the most recent estimates after 2020 are above 200 euro, because it depends on the discount factor we employ. So this is, and we are also finding out that average social cost of carbon is increasing over time. But still, one of my points is that still we are missing part of crucial aspects, such as extreme events. And it's of relevance, presented by our European Environmental Agency or the NOAP in the United States, the relevance of such events. You see here the representation of this historical representation between 1980 until now in both areas, in the US and also in Europe. And you see that exponentially these events are increasing. And are increasing particularly in terms of economic losses. So this is something we should be considering. In the US, they have a database that is called the $1 billion disaster database, in which, as you see, each of the incidents to be accounted for at least provides 1 billion of losses, or generates 1 billion of losses. And as you see, in spite of this truncation, the spread and the projection is exponential. In Europe, it happens a bit of the same. In fact, new estimates released in September 2024 from our environmental agency, the European Environmental Agency, show that there is a crucial estimated damages over time. Our agency indicates that they are using still preliminary data, okay? But in spite of using preliminary data, they are indicating us that in many countries, the losses per capita related to extreme events and weather events is about 1,500 to 2,000 euro. And this is increasing as well. And this is happening while still we are not sufficiently dealing with how to manage and how to model extreme events in the literature. So we should think about maybe new estimation techniques that are coming from artificial intelligence and machine learning that, of course, are already implemented and that can help us with a lot of issues. One of the most relevant issues is that when we include temperature and temperature squared or related variables to temperature, these are highly correlated. And hence, the estimates suffer from multicollinearity, and consequently, it may be that even we have wrong signs. In order to avoid that, we should also think in a more dynamic approach of modeling these aspects, including new techniques coming from artificial intelligence, as we're going to see. Furthermore, nonlinearities. Nonlinearities are crucial and should be considered and should be explored, and this is not minimal. And also, we will see that there are many aspects in which new techniques can help us out in order to develop or to consider other counterfactual scenarios that at times are very difficult to recreate with traditional data. So let me give you an example on how extreme events should be considered and why, looking at the Spanish agricultural sector. And this is a sector that, of course, is very crucial for Spain and also for Europe. This is a sector that suffers a lot from water stress and water scarcity. 90% of our water in Spain is used for the agricultural sector, nothing less, nothing more. And of course, it's a sector that is suffering, struggling quite a lot in terms of new issues related to climate. If we were looking at extreme events related to the agricultural sector, you may not be able to see them properly in this slide, but the first one in your right refers to wind speed. Wind is decreasing over time when we increase temperatures. The second graph on the top is referring to maximum temperatures that are increasing over time. Then we have in the second layer precipitation, and mean temperature that is also increasing. And the minimum temperature is also increasing over time in the last 50 years. We have data from 1920 until right now, 2024. And we have precipitation here. This one is precipitation. So as you see, there are waves in precipitation, but mainly we are in a declining trend. And also wind gas that are becoming somewhat stable. If we are looking at other events that are of crucial importance, we will see that, of course, look at the data. The data is highly nonlinear. The data is at times discontinuous. There are some issues that should be considered. And this is other representation of how maximum temperatures are increasing, mean temperatures and minimum temperatures, both of them, all the series are increasing, are highly exponential. And below you see other events that are also very important. These graphs are one of the most important graphs I ever done in my life as a researcher. And basically what they show is the draw index in Spain, okay? This is data, you will see the comparing data from a span of 50 years, 1973, 2023. And let me show you that the first top right, this graph there in your right, in my left, it represents the February's. February 1973. Here below, it represents February 2023. So in a span of 50 years, you see how also in the winter, at the end of the winter, in February, drought is a problem in the Mediterranean base, and particularly in Spain. But not only in Spain, also France, part of Italy, Sicily, all of these areas are suffering significantly from droughts. And this is something very relevant even during winter time. During summertime is a disaster, basically. You see, this is the summertime, and this is 50 years ago, that was summer. And here below in the right corner to your right, you will see all red. This is summer drought index in Spain, the Mediterranean base, in September 2023. Basically, 70% of the people living in the Mediterranean area are now suffering water scarcity in Spain, and it's expected that this is going to increase even more. So this is one variable that really affects productivity, land productivity, which is not only related to temperature then. Temperature is one thing, but soil composition may also affect draw. If we look at other variables, such as precipitation, we have a similar panorama. The precipitation is decreasing and concentrating up in the north, and the south is every time more and more drier. Wind gust is something that we also include because at times heavy winds destroy the crops, and they are becoming more concentrated in certain areas. Mean temperatures, of course, they have increased in all Spain, but particularly in the Mediterranean area in the south, as expected. Also mean temperatures, not only mean, but minimum temperatures and maximum temperatures. All in all, what I want to show you is that when we consider all these variables and we look into the importance of extreme events into agriculture, in the agricultural sector, and we do it with traditional econometric frameworks, very basic, we're going to discover that when we relate GDP, agricultural GDP, with temperature, precipitation, and other related variables referring to the type of harvest we have and the type of irrigation systems we have, we find out that during the period of 1918 and 2020, about 7.3% of the agricultural GDP has been lost by extreme events, and this has not been accounted for. So basically, what we are in the last years, we also discovered that extreme events play a role as important as changes in temperature. So this is a crucial factor that should be considered later on. This is a basic econometric model with fixed effects, just only for regions, controlling for regions. And it's an important aspect that should be considered. And as you see, usually we don't refer to extreme events in most of our analysis. We also have estimated the curvature between productivity and temperature in order to have this nice shape of how the damage function looks like. Of course, after 15 degrees, agricultural productivity in most areas for most crops goes up, but then it starts decreasing. And certainly there are reductions or changes in very drastic changes in damages according to different regions, like Andalusia and Castilla-La Mancha, Castilla-León. These are affected areas, but not only, also Murcia, because of the water scarcity, and other areas also will be heavily affected. These are changes in temperature. We're not going to be talking about that and how this affects the seasonality of crops. But bottom line, what I wanted to show you in this case study is the temperature, for sure, is a relevant factor, but not only, okay? There are other factors that should be considered. Extreme events, in particular in agriculture, play a crucial issue. Geographical differences are notorious, and hence spatial aggregation basically generates underestimation of damages all over the place. So it will be convenient to look at this with other analytical approaches that we have done, but just for the sake of time, I am not presenting them, also because they are not fully completed. But just that you know, one of the findings that we discovered when we ran my basic forest random model is that extreme events is more important than temperature in the case of agricultural productivity. So based on the fact that I already tried to convince you that extreme events are crucial for understanding the implications of climate change, let me tell you why I think that recently also these aspects related to social perception of risk are also very important. When we think or when we represent an extreme event, there are channels by which this information flows. And of particular importance recently are the role of media, other institutions, and even ourselves as individuals, and how we represent the perception of risk and how we transmit the perception of risk to others. Why? This is essential because, as it turns out, we may amplify certain type of risk or generate additional unexpected activities or additional unexpected threats that generate a hurdle of additional losses. This theory of social amplification of risk is well established in the literature. There are quite a lot of literature referring to Viscusi and his team, how he thought about risk already in the 80s, and how they measure risk related to extreme events. But recently we see that this literature is emerging and coming back in order to try to understand also how people behave, for instance, in drastic situations, such as in terms of wildfire risk. What do we do there? Do we evacuate? Don't we evacuate? Why? How we perceive it and how we understand it and how we behave. Also, pandemic, COVID-19, all this misinformation dealing with vaccines and how the influence of certain type of media have exacerbated certain behavior. All this comes into play again and make us reflect on the social aspects of risks. And we saw before that when we look at extreme events, there are additional considerations to be included, and not only the economic ones. I showed you this map of interlinkages of risks, and this is what I want to show you here. So when a drastic event happens, of course, there is information, personal experience of the affected individuals, there is behavior in terms of the institutions, and so on and so forth, that translates and that generates all a certain ripple effect. And this ripple effect may provide unexpected consequences. For instance, political change. At times it happens or is affected, the political power, by the occurrence of extreme events. This usually has not been studied, but it should be also a topic of further analysis, also in economics, and many others. Or like reduction of trust in certain institutions, and particularly also in academic institutions. When we look at social media and the fact that social media has, and in order to understand how information is transmitted on social media, we have been collecting a data set of tweets worldwide in order to understand how people talk about climate change. And we have about geotag data for 11.5 million tweets worldwide from 2018 until 2022 that allow us to understand many dynamics on how people perceive risks and risk associated to extreme events. This is a database that I'm going to show you now, only containing Spanish tweets. And the reason is because in that case, I can focus and relate local aspects, where they are happening, and how people are tweeting about those. I learned how people have tweeted during COVID-19. I learned that prior to COVID, climate change was a crucial topic on social media. When the COVID came, of course, there were other issues and concerns to be dealing with. So during 2020, the COVID conversations flattened down. And they start emerging again in 2022, but still not yet to the level prior to COVID. And when people talk about climate change, what do they talk about? Do they talk about the fact that, well, the summer is extending a bit more? No, not really. They talk about extreme events, basically. And they relate on, and which is unfortunate, they relate climate change only to extreme events, or mainly to extreme events. And this is also a shortcoming in terms of communication, how we should be articulating communication related to climate change. If individuals only consider or talk about climate change when a drastic extreme event happened, that's not very productive in terms of implementing other policies related to maybe taxation or maybe many other things. So what we have done is to collect all these tweets and use natural language processing to estimate how people are perceiving climate changes, or changes in climate, sorry, or impacts to extreme events using this technique, NLP. And basically, what we come up is with scores that allow us to understand how sentiments over climate change are changing, right? Sentiments can be positive or negative, and for the sake of time, I'm not going to tell you the libraries that we use, but these are fairly common and popular, Affine and Vader in these two cases. And what we do is we introduce the text data, and the text, the algorithms call certain dictionaries that relate each of the words with a particular meaning, positive or negative, and with a particular sense, strength of positiveness or negativeness. For instance, fiesta. Fiesta is one of the most positive words in the Spanish language. So when the algorithm detects you are talking about fiesta, for example, it gives you a very high score on positiveness. When the algorithm detects you are talking about death, it gives you a strong negative value, right? Where these values are coming from is called a library. So there is like a library full of, imagine instead of a description of books, now they describe how this text should be translated into a numerical score from 1 to 10. And where these scores are coming from? Usually from us, individuals. This has been pre-tested with many people around the world to test what kind of strength do we give to this kind of words, okay? So in general terms, then you aggregate the scores in a sentence and figure out whether this is a highly positive, highly negative, and to what extent. And there are different formulas, and there are different rules of aggregation. And these are the difference of the various dictionaries or families. Just to give you an example, Bader. Bader is one of the most sophisticated machine learning techniques nowadays for text analysis. And basically, they even collect information from emoticons. So they can translate the emoticon into a positive feeling, a negative feeling, or an indifference feeling, right? So there are different rules, at times based on heuristics, at times based on really machine learning, that provide the general sentiment to the tweet. And consequently, due to aggregation afterwards, we can figure out whether the conversations tend to be more positive, more negative, or if they are switching over time. Here we see that in most countries there is a negative feeling or a feeling very close to zero in terms of conversations related to climate change. But let me emphasize that this negativeness was much stronger prior to COVID than after COVID-21. With respect to the different countries, most of them suffer or have very strong negative effects, except Costa Rica. In Costa Rica, they do not have a very negative perception of climate change, but in general terms, in all countries in which Spanish language has been registered, including USA, there is a negative feeling associated with climate change. And this feeling is strongest than ever in Chile. Chile, as we know, is a country that has been highly affected by droughts in the last couple of years, and as a consequence, there are many negative conversations with respect to that. The same with the other library affine, we get similar results. Again, Chile, highly negative, and there Costa Rica appears with a slightly negative instead of the prior slightly positive. And if we look at the sentiments per month, of course, they are also decreasing with respect to, in the summer, they are the most negative occur in the summer from June to September, and then there are more positive feelings about, in general, weather, not climate in this case. If we compare sentiments prior and post-COVID, as we were saying, right, there is, depending on the country, in some countries has exacerbated a negative feeling post-COVID, but in many, they are still not recovering this negative feeling. But I wanted to talk to you is one last development. And the last development occurred in Valencia with the DANA, or DANA is it means depresión aislada en nivel alto, so it means like depression and high levels of the atmosphere. And basically, what you have seen in the news, this is a very drastic extreme event that just happened now. From yesterday, there was a total count of 222 deaths and 5 missing people. And one concern we have when we look at this extreme event is the misinformation. And that's the part of social amplification of risk that I want to bring up to the table. And I want to bring it up in spite of us being most of us economists. And why? Because we are looking into a new toolbox of type of risks, and we are looking into a new framework of analyzing risks. We are just not looking at economic risk per se, but we are looking at all that type of information fluctuating that is actually affecting how individuals behave, which at the same time increase the risk of deaths, for example. This is not only proper of Spain, it happens in the last couple of years in most extreme events. There is a huge circulation of miscommunication and misinformation. For example, already the US authorities blamed the fact that in the last events occurring in Florida 1 month ago, there was a lot of misinformation provided apparently by Russia. I don't know, this is what the news were saying, that Russia has supplied a lot of images that were basically created with artificial intelligence to show realities that didn't occur. In other cases in Florida, also there was misinformation with respect to the impact of the storm. And that precluded some individuals for the evacuation, and they decided to stay, and as a consequence, they die. So what I want to tell you is a bit on how people perceive this, the conversations, and how we look at the implications that they had in looking, in this particular case, at Twitter conversations. We have around 100,000 data points, tweets related to the data, our data set. The data started on October, 29th of October. And as you see, the first day, there's like a positive even during lunchtime and after the afternoon, a quite positive sentiment of what was happening in that particular moment. Surprising, right? How can you have a positive sentiment with respect to an extreme event like that? And our algorithms, and we have checked that, only detect a very negative sentiment after 8 o'clock, and particularly at 12 o'clock in the night. During this period, there was a round press by the Malaysian president indicating that 2 people at least had died. So they start thinking that, well, we have a problem here. But prior to that, as you see, it was a normal day. A normal day while the Spanish meteorological services were indicating that a huge storm will be occurring in the Mediterranean area. This is important because we estimated the sentiment per hour of all our tweets, and we verify one after the other, and we verify one after the other algorithm and one after the other way of measuring this, that there was really a problem with information and misinformation in the very first day of the occurrence of the data. Why we know that also? We know that because also when we split the total number of tweets we have by the sender, which can be news media in blue, or emergencies, or emergency offices, or Cruz Roja, Red Cross, and other organizations specialized in emergency and rescues, and the general population, we observe the following. The media, from 8 to 9 in the morning, in spite of that being already announced by the Spanish Meteorological Center, practically the media, on average, they did not report about the data, and when reporting, it was a minor thing. So you see a positive sentiment with respect to all the news that are sent that day in the morning to the Valencian population. You see that, nevertheless, as the day passed by and the emergency services started to describe drastic situations out of limit, things are starting to become worse, much worse, and worrisome even. But I wanted to highlight the fact that there we have not only misinformation, but wrong information. So what we are doing now is try to understand the dynamics of fake news related to these drastic episodes, and differentiating between misinformation and disinformation. Misinformation is when there is no information about an event, and disinformation is when you minimize an event that is expected to be huge. And we have some research hypotheses, and this is an ongoing project because we are still collecting data. But one of the most important features we are finding out is that the fake news spread faster than real news. And there are important issues for that. Fake news, point one, are fabricated. And as a consequence, they are potentially emotionally charged, they are used as marketing strategies, and the messenger has particular market power in order to establish this news as, like, let's say, an opening of a newspaper or an opening of a website you visit, and so on and so forth. Additionally, fake news contribute to the polarization, and this is something we want to test. But because of how they are written and the frequency they are written, they make more difficult to reach consensus. And as a consequence, they are very negative for emergency situations. They freeze the society, basically. And furthermore, they erode the trust and the confidence in science and in other institutions. In particular, like in Spain right now, there is even a lawsuit against the some meteorological stations that operate in Valencia. So in sum, what I wanted to tell you today, is that we should be much more concerned about extreme events from the analytical perspective, thinking on how we should consider them in our damage functions, in our integrated assessment models, in any other modeling framework we will apply from the economic standpoint. But also we should think from a societal perspective, how this should be integrated into a broader toolkit. Why? Because we are observing that risks are highly interrelated. There is a huge potential failure of systematic risks worldwide. We should be aware of that. We should understand the correlations between risks, and we should also understand that these are not separate boxes. There is a huge interconnectivity between different events, and particularly huge drastic natural events, and other different events, such as political establishments, such as reputation of institutions, and so on and so forth. And in sum, as climate economics is basically a science to deal with risk allocation, basically, and risk minimization, we should also think on what is the role we are supposed to take when we work on this area and we bring realistic case studies to this area. And with that, I open for questions, and I thank you for your time.
Thank you, Maria. Super interesting and super timely topic. Before opening to questions, I have two questions myself, because this is close to my heart as a topic. The first question concerns the use of Twitter. Oh, yeah. Because, as you know, we were trying to use it together for a paper. And I wonder whether there might be a problem in terms of selection bias in using Twitter, because many of us are leaving Twitter because of Elon Musk. And the second question is somehow related, I'm afraid, because it relates to the social cost of carbon and to the possible misinformation behind it. Actually, this is not my question. It's a question that my students asked me before I left to Baku, and I said, I'll think about it. I don't have an answer. And the question was, how can we trust the social cost of carbon given that the discount rate has been used so differently? For instance, Biden administration, 2%, but with the previous Trump administration, I remember correctly, 7%, and now Trump is back. So maybe things change very drastically. So the question was, is it scientifically robust? And I said, let me think about it. I would like to say yes, but I'm not fully sure.
Yeah, well, thank you for your questions. It is true, Twitter. Well, Twitter is true that it's becoming a more right-wing communication channel. That's absolutely true. We collected it, but we are also collecting other data, but it's taking longer. But it's true that what you are saying. Nowadays, Twitter is not as neutral as used to be in my previous studies. That's correct. Said that, now we are trying to collect also additional data from other social media, but it still is the most popular social media platform, and that's why I consider it. But good point, and I agree with it, absolutely, it's true. Furthermore, it should be complemented with additional data in order to provide a perspective of what I just said. But this does not invalidate, unfortunately, the main results, because in the information box, we can separate left-wing from right-wing media. And there is also a very interesting result. There are some very interesting results, but it's still very preliminary in nature that I prefer not to disclose yet. But for sure, Twitter nowadays, it suffers from a bias worldwide, correct. It should be complemented with additional data sources when possible, and we are trying to do that with TikTok and so on and so forth, but surprise, they are also right-wing. Hello, all of them, mostly. And, and that's an issue, right? There is no perfect complementation of Twitter. There are, because the largest social media outlets out there, they have all of them, each particular problem. Said that, we are still working on that. We acknowledge the issues we indicate, but we are also very concerned that in spite of this, it's still the most predominant media. With respect to the social cost of carbon, it's true that at times, not at times, but the discount rate is also is mainly, let's say, a political decision to be taken, and does affect the robustness of the social cost of carbon for sure. It affects the estimate significantly. And what should we do then? Well, we should use scenarios. We should use brackets rather than data points. We should use a broader perspective for decision making, which still will be good for decision making, but not necessarily looking at the point, meaning the point, of course, is going to suffer, the point estimates are going to suffer, and what we should then look into this is, well, all this risk mitigation analysis we know how to deal with, right? Scenario analysis and uncertainty analysis in order to figure out how things will evolve. But certainly this will be an issue to be discussed in the next months. And it doesn't look so good, I have to say.
Thanks a lot. Very clear answers. I open the floor to questions. We still have 7 minutes to go. Mira, please introduce yourself.
Hi, good morning. My name is Mira. I'm a researcher here with our team that Simone mentioned this morning at FSR and at the Global Governance Program and in Siena with Simone. Thank you for your presentation. I really liked the progression from where we have the theoretical framing in terms of how we see or how we've not seen extreme events, and then empirically what we're seeing in users. This is purely speculative, but I wonder if you see that there might be a divergence between not only what the models didn't take into account, Nordhaus's and Stern's, and what the public is focusing on today, how they focus on extreme events, but also what might have remained in the public imaginary, in the public discourse around climate. So that on the one hand, empirically, they're talking about extreme events, they're associating climate predominantly with extreme events, but whether the path dependency at a mental and psychological level remaining from those models that didn't take into account extreme events and tipping points in our measures of GDP effects, in our measures of what would be an ideal temperature rise, whether that framing is still dominant in how we see climate different from how we talk about it at an empirical level.
Yeah. Yeah, that's a very good question. It's a very suggestive indeed. And it's true. How people perceive things are at times rather different than how we in economics we try to model them. And yeah, there is a path dependency in the literature, but nothing excludes you from put forward your thoughts and add additional variables to this framework, which is pretty good, which is really, really good. And just because they did not include extreme events, because they were much more extreme in nature than what they are now, in the sense of low replication and so on and so forth, does not imply that their formulation is incorrect either. So we are very lucky that we have this robust economic modeling out there that we can use. There are plenty of integrated assessment models nowadays. There is lots of knowledge and even in open source so that we can go ahead, download them and transform them into something that we may consider more realistic for the time being. And this is what I encourage people to do, right? And there is a certain path dependency in the literature, but more and more it's observed that this was a good basis to start with and it should be enriched later on. And this path dependency happens only in science because the public goes thinking something else. They don't have this formal knowledge of nature that we do. And as a consequence, they perceive it based on their experience, on their day-by-day activities. And of course, they have a different vision about climate change and their impacts than we do. And part of our work is also to transmit things they don't do or they don't see, right? They may not see, for instance, how the draw index has changed in Spain and what consequence that has over well-being, over ecosystems, over their lifestyle, although they acknowledge that they are starting to think, well, this is kind of normal. I have only a few hours in the morning of water and a few in the evening, and that's it, ciao, ciao. No? But that shouldn't be that normal, right? They normalize behavior that should not be normal to start with, right? So they have a huge resilience as well, and we should applaud that. But our work as scientists is also to let them know in objective terms what data tell us without any manipulation, right? I think this is our work as well. And they need that more than ever, maybe.
Time for Mathieu.
Yes, I'm Mathieu Glachant from Paris, PSL University, Mainz Paris Tech. A question on the way you measure this positive and negative sentiment. When you communicate is to say something new. So we say good news, bad news, okay, something new. New, it means that you compare it to the past news. It means the past stock of news. And when you say, for instance, your example that there were positive sentiments expressed in the morning in Valencia. Mm-hmm. So you take the example by saying it would be a minor flood. So in comparison with what was being said before, which was something major or something like that. So there's a dynamic element here. How are you able to tackle with this? You know, because you can have, for instance, just one extremely bad news, and then a series of what you call positive news, which are simply the learning that the bad news is not so bad. So yeah. How do you manage this timing effect? And this is my question.
Matthew, I didn't hear you well. I don't know if Simon heard you well, the question. Here I couldn't get it fully. I got a feeling of what you asked, but did you hear well, or should I?
Well, I think the question is, there is a stock of past news, yes. And there are news. They can be good or bad, but also bad news compared to the previous ones may look good because it's not too bad. Am I correct, Mathieu? So how do you adjust for this aspect?
Oh, good question. Thank you, Matt. This is a very good, smart question. Yeah, there is a stock of news and there's a flow of news, right? There's a flow and there's a stock, yeah? So what I have presented is the analysis of the flow, right? Just for time, for lack of time and brevity, I went on only on the news that have been published that particular day, and on the tweets published that particular day. Prior to that, you say, yeah, there is a stock, hey, you. And it's true, there is a stock. I didn't have sufficient time to tell you there is a minor stock for this particular event in particular. A very minor stock of news. And this very minor stock is also a problem because there has been misinformation and lack of information, both things. So we have the historical, how do? We collect prior to the data, of course. So we have a baseline of sentiments and sentiments per day, and we have the baseline of information flows, information stock prior to the event. And then we can treat the tweets occurring during the event, right? And with that, we sort of analyze it like some event study type of thing, right? So for the lack of time, I didn't include, because it also takes a lot of time to analyze it, the stock of prior information. But the stock of prior information should be on the 28th and on the 27th, right, of October. And I have to tell you that in this particular event, it lacks of strength because basically there was no prior information with respect to the event. And how do we then account for the fact that bad news are not so bad and all that? That will be a good, it is still a very relevant question, but it does not apply much here because of the lack of prior news to the event, right? It is true also that may occur a relief effect in which it was not so bad after all. But we cannot test that because, as I say, prior news were extremely minimal and minimized in this event. Other thing that you say is how do we control for the cascade, the informational cascade. You didn't call it that, but I understood that you were thinking about it. And this can be easily controlled for or analyzed with the retweeting activity. Because we have tweets and we will have retweets. And the retweets will give you also the cascade. And that's very interesting as well, because in that way you can see how prominent is the evolution of fake news with respect to regular news or correct news, right? So we are able to control for the cascading effect through the retweeting. And furthermore, we also have information on who owns that account. Is the BBC who owns that Twitter account and has, let's say, 3 million followers? Or is it the right-wing party that has 100,000 million, but they are super activist and they don't stop, they are writing every single moment? And we have all these kind of dynamics into the data set still to be explored.
Okay, I think we should stop here. Also to have the time to tweet. That this was a great keynote, and really thank you, Maria, for this. Thanks a lot.